Next question is question 27. It is marked by, 37. It is marked by a star because it has a concept we didn't really talk much about. So let's call this optional. It's not that hard, so that's why I want to go over it. Good question, valid question in real life. A roller coaster descends from 55 meters at the top, which is the highest point, to the first low point on the track. The roller coaster, as we know, converts gravitational potential energy to kinetic energy. And here's the keyword: with an efficiency of 50%. What is the velocity of roller coaster at the bottom of the low point? First low point. I make a drawing where I only have one low point, but the drawing is really redundant, not necessary. Because what happens here, as we know, the potential energy converts to kinetic energy, but in our case it says the efficiency is 50%. That basically means that not all potential energy will be converted to kinetic. There'll be energy loss, which is inevitable, which is usually the case. So how do we measure that? Let's calculate potential energy. And now I notice that I write the formula mgh, that m is not given. There are multiples of ways to go about it, and I'm going to show you one very untraditional method. You can just take m for any number. It's not given because potentially in future calculations it will disappear, cancel each other, but maybe we don't see it right away. So for that reason, let's just take m for any number. How about 1 kilogram? It could be 10, it could be 100, it could be any number. So I'm taking 1 kilogram, keeping the height of 55. So 1 times 9.8 times 55, 539 joules. This is potential energy. Now this energy converts to kinetic, and I wish I could say that kinetic is equal to this number. But no, I have to take half of it. So 1/2 of 539 joules will be 269.5 joules. And that is what will be used for mv squared divided by 2. V from here, square root of 2 kinetic energies divided by mass. And we will reuse the mass that we invented. So let's see. 2 kinetic energies. Ironically enough, we just divided kinetic potential energy by 2. Now we're multiplying back. This is not related to each other. If the percentage was different, this would be a completely different story, but I already know that it is 539. I need to take a 539 square root out of that number, and it's 23.24 meters per second. Now, optional thinking, not apologize. You could ask, okay, fine, you invented this mass of 1 kilogram. How could you go about it without inventing mass? Fine, I can do that. Potential energy, mgh, it converts to kinetic energy as 1/2. And it will be equal mv squared divided by 2. Notice how many things? 1/2 m. So we will have that v is equals square root out of gh. which is 9.8, 55. I have the feeling it's the same 539 and 23.24 meters per second. So I will underline where I incorporated the percentage. This is the 50% efficiency. That's how I incorporate 50% efficiency. Same here. If there was a different number, less than 50%, more than 50%, the coefficient will be different. And that's how we solve this problem.